Hey folks, this calculus lesson is on integration by substitution. So we're going to do some U-substitution here. So recall that if you had the function f of x equals the quantity x to the fourth plus 1 to the third power, then the derivative would be this power would come out in front, the 3, and you decrease the power, and then you multiply it times the chain inside. So this is the chain inside would be 4x cubed, okay? With me? So where the derivative is, you subtract the exponent, you multiply the exponent and multiply by the chain, okay? So I subtract this exponent from here to here, and then I multiply by the original exponent and then multiply by the chain. All right? Integration or antiderivative is doing the opposite, you guys. Instead of subtracting the exponent, you add the exponent. Instead of multiplying by the exponent, you divide by the exponent and then divide by the chain. All right, but we're going to show you, I'm going to show you this by doing what's called a U-substitution. I think the U-substitution is sweet on this, you guys. Let's check it out. All right, so what I always do is I let the U-substitution equal the inside stuff, you guys. The more complicated stuff in general, it's usually the complicated stuff. So I'm going to let U be the inside stuff. So when I derive U, then I take the derivative of this. So du is going to be 2x dx. That's what this says right here. Okay? And then check it out right here, you guys. Here's a x, here's a dx, and then so here's the x dx. Whoops, so here's the x dx right there. So if I divide both sides by 2, I get du over 2 equals x dx right there. And so here's my x dx. That's going to be du over 2. So I'm going to pull this 1/2 out right here, and this is going to be my u right here. It's going to be u to the 5th, and then the x dx, the 1/2 comes out. Okay, do you guys follow me with that? So these two guys get me du over 2, and this is u right here. And then so I'm going to get the 1/2 u to the 5th du. Okay, and then we just derive or integrate just like we did before. We add an exponent and divide by the exponent. Okay, don't forget your plus c, you guys, because this is an indefinite integral. There's no numbers on it, so don't forget your plus c. I know some of you guys still are, and your calculus teacher will take off points if they're anything like me, and I know they are. They're probably much better than me anyway. So so you get 1/12, and then go ahead and put your u back in. My u was x squared minus 2, so it's u to the 6, so it's x squared minus 2 to the 6. Don't forget your plus c. All right, let's try another one. This stuff is bomb, you guys. Oh yeah, and to check this out, you guys, to check your answers, take the derivative. So if I took the derivative of this 6 would come floating out in front, so there it is right there. Decrease it by 1 times the chain. The chain is 2x, and the 6 and this 2 and this 6 makes 12, and cancels out that 12, and I have the x, and so it came out with what we started with up there. Okay? Cool, huh? All right, let's try another one, you guys. All right? Okay, typically, you guys, u is the inside stuff, so almost always u is the more complicated stuff in general, you guys. And then your du is going to be a form of the leftover stuff. And when it's not, it's another trick I'll show you guys later in the next few lessons. Okay, so u is going to be the inside stuff, so du is going to be 3x squared dx, and then divide by 3, and I get du over 3 equals x squared dx. Here's my x squared dx, so that's my du over 3. So I'm going to pull the 1/3 out, and I get that my u, there's my u right there, x cubed plus 1. Square root of that is u to the 1/2. Okay, and I'm going to add an exponent and divide by the exponent. Okay, so there it is. Add 1 and then divide by the new exponent. Okay, and I'm going to invert and multiply this guy, so it becomes multiplied by 2/3. So you get 2/9 right there. All right, and then let's go ahead and put it back in radical form, so that one looks a little bit cleaner right there. Okay, that's cool, huh? All right, so try this one here, you guys. All right, it's important to know which one's the derivative of the other. Okay, so the derivative of tangent is secant squared, so I'm going to let u be tangent of x plus 3, because the derivative of 3 is just 0. All right, so let's go ahead and do that. So u is the tangent of x plus 3, so du is secant squared x dx. Okay, now this is just a nice substitution right there. Okay, so secant squared x dx, there's my secant squared x dx, that just equals du. So that's what this part is right here, du. Okay, here's my u. All right, so add 1, divide by the exponent. Okay, and then go ahead and plug it back in. There you go. All right, they might put a 1/2 out in front. They might say 1/2 times the quantity tan x plus 3 quantity squared plus c. Don't forget your plus c. All right. All right, so this guy right here, I'm going to let u be the 5x. So du is 5 dx. Okay, so dx is going to be 1/5 du. All right, so the 1/5 is going to come out in front, and then the cosine of u, the integral of that is sine of that, so it becomes 1/5 sine of, now go ahead and put your u back in, 5x plus c. All right, let's try another one, you guys, okay? Now, again, you guys, these are both derivatives and integrals of each other, so it just depends on which way you want to go. I'm going to go ahead and let u be the sine of x, because then it's squared right there. So du is cosine of 3x dx, okay? And then so the 1/3 is going to come out right there. All right, you guys with me right there? Okay, and then we're going to go ahead and add an exponent and divide by the exponent. So there's my u squared right there. So you get 1/9 the sine of 3x and then cubed. Okay, sine cubed of 3x. All right, so there's your answer right there. All right, easy enough, you guys. I like this section right here and the next couple ones coming up right here. If you're in my calculus class, I would assign that for your homework. Take care.